Today you will practice solving radical equations. So when solving radical equations, notice we have some form of square root or cube root, and our steps include isolating the radical, squaring both sides to get rid of the square root. Remember, that's the opposite of square root. We're going to solve for x, and then we'll check for extraneous solutions. Now, if you've forgotten what the extraneous solutions means, that just means solutions of x that when I plug them into the original equation, they do not make a true statement. So let's just start off with the first step. Is our radical isolated? In this case, yes. So we're ready to move on. So step 2 is to square both sides. So we will do as such. When we square a square root, remember the square root symbol goes away. So we're left with 3x minus 6 equals 36. If we look at our next step, we're going to solve for x. So how do we isolate the radical? Well, we notice there's a subtract 6. So we're going to add 6 to both sides. Drop the 3x, drop your equal sign, and 36 plus 6 is 42. Now to isolate the x, the opposite of multiply is divide. So we'll divide both sides by 3. And notice 3 goes into 42 14 times. Now, if we were to check for extraneous solutions, if we were to use a calculator and do 3 times 14 and then subtract 6, does that equal 6? Yes, it actually does. Yay. I want you to take a minute or two and try the example you tried. Hopefully you found x to be 38, and when you do replace the x with 38 and simplify with a calculator, it does end up equaling 9. Both sides. Okay, so let's do another problem. First question, is the radical isolated? In this case, no, because the plus 4 is not underneath the radical sign. Remember, the opposite of add is subtract, so we'll subtract that 4 on both sides first. So we'll have the square root of 3x minus 8 equals negative 4. Now remember to undo square root. We will square both sides. Now, what happens when you square a negative? It becomes positive, right? The left side, remember when you square square root, it just undoes that operation. And now we're going to say, okay, how do we solve for x? Well, we're going to add 8 to isolate the x. So 3x equals 24, and then divide by 3. And we do get x equals 8. Now, when we check for extraneous solutions, we have the square root of 3 times 8 minus 8 plus 4 equals 0, or the square root of 24 minus 8 plus 4 equals 0. Is the square root of 16 plus 4 equal to 0? No, right? Actually equals 8. So in this case, we have no solution. I want you to take a minute and try the example you tried. Okay, so hopefully for this one, you did get x equals 13, and 13 is not extraneous. Oh my gosh. Okay, so this problem looks weird and different. Well, if I have two radicals, remember, and I have 0 on the other side, I'm not going to square both sides right away because that means I would have to FOIL or distribute in order to simplify. And I don't want to FOIL two different radicals. That sounds like a headache. So instead, we are going to actually add the square root of 6x plus 5 to the other side first. Okay, so notice we have the square root of 7x minus 1 equals the square root of 6x plus 5. So now that our radicals are isolated, we can square both sides. And when we square both sides, the squared undoes the radical. So 7x minus 1 equals 6x plus 5. Now what side would you like your x's on? Well, I'd probably choose whatever side is going to give me a positive number. So in this case, I'm going to subtract 6x. And then we're going to add 1. And we do get x to equal 6. All that's left for us to do is to check for extraneous solutions. So we're just going to plug that into our original. We know 7 times 6 is 42. So we have the square root of 42 minus 1 minus the square root of 6 times 6, which is 36, plus 5. Does that give me 0? So we have square root of 41 minus the square root of 41. Does that equal 0? Yes, it does. I want you to take a minute and try this example you try. Okay, so this one is a no solution. When you do type it into a calculator, remember it will not find a negative square root. It's actually a complex solution, so we say no solution. Equals, okay, so here is our last example today, is our radical isolated. And in this case, yes, so we're going to go ahead and square both sides. Remember, when you square a square root, it undoes the symbol, so we'll just be left with x squared minus 9x, and on the right side we'll have 36. Now, because we have a degree of 2 here, that means we have a quadratic equation, and we have to make it equal to 0. So we'll actually subtract the 36 on both sides so that it equals 0. So x squared minus 9x minus 36 equals 0. And just like we did earlier in this unit, we can solve this guy by factoring, or you can do quadratic formula, it's your choice. Factors of 36 that give you 9. Well, we know x times x equals x squared, and factors of negative 36 include things like 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So which pair is going to give me 9? Looks like 3 and 12. And we want positive 3, negative 12. And remember, we set each of those factored pieces equal to 0 next. So x will equal negative 3, and x will equal 12. When you do the check, this time you need to plug in both solutions into a calculator or into a piece of scratch paper. We know negative 3 squared is 9 minus negative 9 times negative 3, which is positive 27. Oh, that's a 2, which does give us the square root of 36. So we know that negative 3 is good. If you check 12, we know 12 squared is 144, and 144 minus 108 for 9 times 12, right, is the square root of 36, okay, which is 6, which is the right side, so that one is good as well. Take a minute or two and try the last example you tried. Okay, so this one was a little trickier to factor because factors of 64 that subtract to give you 12 would be positive 16 and negative 4. When you do plug those into the originals, the negative 16 squared is positive 256, and 16 times 12 is 192, but because the 16 is negative, you subtract, and you do get 8. And for 4 squared is 16, plus 12 times 4 is 48, which gives you the square root of 64, which is 8. So both solutions actually work. And guess what? You are officially ready for some practice. The end.